Saturn's rings are made of ice and rock. That part we know. But something is making shadows appear on them, drift across them, and then vanish. And after decades of watching, we still aren't totally sure what it is. Whatever is causing these shadows, they don't behave the way solid objects should. They rotate around Saturn faster than the laws of orbital mechanics say they ought to, and they seem to appear more often at certain times of year and almost vanish at others. Scientists spotted them first with Voyager 2 back in 1981, and the name stuck immediately. Spokes. Like the spokes of a wheel, dark radial streaks spreading outward across the B ring. Look over here at this close-up on the right side of the frame. The label says spokes, and if you stare at the ring plane, you can just make them out. Faint, dusky patches running across the rings like something wiped a thumb across them. They're not gaps in the rings. They appear to be tiny grains of dust and ice that have been lifted off the ring surface, levitating above it. And it's that height difference that lets them catch or block light differently than the ring itself. The leading theory is electromagnetic. Saturn has a powerful magnetic field, and the solar wind, that constant stream of charged particles flowing out from the sun, interacts with it. That interaction may be flinging tiny charged particles upward off the rings. And here's the seasonal part. Near Saturn's equinox, when the rings are tilted more edge-on toward the sun, the spokes go wild. Saturn's equinox only comes around once every roughly 15 Earth years, so we don't get many chances to watch. Cassini caught one full cycle before its mission ended in 2017. Hubble is watching another one right now. So here's what you're really looking at. A planet 1.5 billion kilometers away, with a magnetic field and a solar wind conspiring to lift ice off its own rings and cast shadows with it. We have the what, we have some of the how. We're still arguing about the details, and every 15 years or so, the geometry lines up again, and we get another look. What do you think we'll figure out this time? We'll be here tomorrow with whatever the selector finds next. Subscribe so you don't have to remember to come back.